In this video, we're going to take a look at the integration by parts formula, which gives us a way to solve certain problems. We'll discuss what type of problems these are and then run through an example to demonstrate this. So let's start off with the formula, and you might see this written in multiple different ways, but I'm going to go with the one I'm most familiar with. So that is the integral of u, which is some function or variable, multiplied by the derivative of some other variable v, some other function v, with respect to x, and this is all integrated with respect to x. So this integral is equal to the functions multiplied together, u and v, so u and v are both functions of x, minus the integral of v multiplied by the derivative of u with respect to x, and again this is all integrated with respect to x. And this all looks a bit complicated and might not be apparent why this is useful. Essentially what it allows us to do is, if we're integrating two functions of x that are multiplied together, using this formula to convert it to this form can make it easier to solve. And we'll see an example of this now. So let's take our integral and we'll call it I, and we want to integrate the function x times sine x with respect to x. So the trick with integration by parts is deciding which function you're going to take as u and which function you're going to take as v. So here I'm going to select u is equal to x, and I'm going to take dv by dx is equal to sine x. So what I'm saying here is I don't yet know what my function of, what v is, but I'm going to take dv by dx as sine x. I'm going to say that the derivative of my function v is sine x. And the reason I'm doing that is to match up with this formula here. So I've taken a u and I've taken dv by dx. Okay, so now my integral looks like this side of the equation. Okay, so I can now use this formula or this identity. So now I know, so now if I want to use this formula, I need to know v and I need to know du by dx. So I'm going to calculate both of these things. So du by dx, well, the derivative of u with respect to x is the derivative of x with respect to x, which is just 1. And then v, when we integrate sine x, that will give us v. So the integral of sine x with respect to x is minus cosine x. Okay, so now plug in all these values into the formula. We get that the integral evaluates to u times v, so that is x times minus cosine x. So that is minus x cosine x. And now the second part of this formula here, we've got the integral of v multiplied by du by dx. So that's, sorry about that, that is v, so minus cosine x times by du dx 1. So inside the integral we'll have minus cosine x. We can bring the minus sign out and we get plus the integral of cosine x dx. And if we evaluate this expression, we get minus x cosine x. The integral of cosine x is sine x. And then, as always with integration, we have a constant of integration that we'll call c.